and that will hopefully help each other know who's in the room. And then also you have a poll that you have been responding to, and just so that Colin knows who's in the room. Again, our little virtual room. Lots of folks that live and work in Baltimore. So welcome to all of you. We have folks from the public sector here, predominantly actually, and then nonprofit, and then folks in the community, universities, and students. So a broad range of folks, a broad range of skills, which is awesome. The whole point of Baltimore Data Week is to bring a variety of different folks together to learn about data for our neighborhoods. So without further ado, I'm going to turn it over to Colin. His bio is going to be in the chat, and he's going to walk us through how he's been using BNIA resources in ways that we might have not even ever thought of, which is the amazing part of open data and watching all of you take the helm of understanding our city, using data to understand our neighborhoods. And I want to welcome our fellow colleague, Colin at the University of Baltimore, and take it away.
Great. Thank you so much, Priya, and thanks to everybody at the BNIA crew for putting this together and allowing me to present on using BNIA data and their API to visualize the black butterfly. And I'd like to start off, for those of you that don't know what the black butterfly is, to give credit first where credit is due. This is the book. I can see it's my virtual background is messing with it a little bit. It's by Dr. Lawrence Brown. And the black butterfly describes kind of a shape that he noticed when you look at the residents of Baltimore City and you plot where predominantly black neighborhoods are versus predominantly white neighborhoods. You see that the black neighborhoods form what look like the wings of a butterfly. And the predominantly white neighborhoods are sort of the body of the butterfly, but it's a little bit in the shape of an L, and it's sometimes he refers to it as the white L. And it's not just, importantly, it's not just a shape. It really lays out a concept of hypersegregation that he develops brilliantly in his book as well as in other writings. And the idea of the black butterfly, it's where, I'm quoting from him directly, it's where black Baltimoreans are geographically clustered and where capital is denied and structural disadvantages have accumulated due to a lack of capital access. So it's really a geospatial concept that's key to the notion of structural racism. And indeed, his thinking around this has helped me think that the very concept of structural racism is, in very many ways, a geospatial concept that's connected to the notion of hypersegregation. And so the way I came to this particular panel today, or giving you this talk, you should know that I have for a long time been working in the pretrial justice space here in Baltimore City. What we used to call the criminal justice system, which now most advocates and activists call the criminal legal system, to emphasize just how little justice there often is. But I've been working, I'm a law professor, and I have been working with students, working with the Office of Public Defender, representing people, defendants in bail review hearings, and becoming part of generally the bail reform movement here in Baltimore City. And across the state. And as part of that, last summer, I teamed up with a professor at the University of Maryland who's been doing this kind of pretrial justice work for many, many years, for 20 years. His name is Professor Doug Colbert. And we were granted permission to attend every single bail review hearing in courtroom 4 in the months of June and July. And we collected a lot of data around that, all right? And the other part about my background that you should know is that I teach a legal data and design clinic now, and Seema was generous enough to come and speak at our class. And we do a lot of kind of working with data, designing data, and working actually with coding concepts. I teach coding for lawyers as well, to do data science. It's sort of data science for lawyers, right? And in anticipation of Seema's visit to my class, I learned something that we'll talk about a little bit more, a type of Python library called Geopandas, which lets you essentially take GIS mapping data and create visualizations with it. And when I did that, I ended up saying, I wonder if I could apply that to my bail data that I collected over the summer. And I learned how to take defendant addresses, which you can get from K-Search, convert them into latitude and longitude type coordinates and map it, right? And so I'm going to share my screen for a second now. And I'm just going to show you what I saw. So this is when I mapped, this is just mapping defendant addresses. And I saw here a shape that I was like, my goodness, that is a black butterfly. I can't believe it. I mean, I could believe it. I shouldn't have been surprised. But I actually realized that the black butterfly concept that Dr. Brown had been talking about was something that I saw in my very own data, and that I shouldn't be surprised about that, because of course the criminal legal system is connected to the problem of hypersegregation. They're all connected. And that got me thinking that really I should be focusing more on this notion of the interconnectedness of different systems. Something Seema spoke about when she spoke to my class is that if you look at the neighborhoods that have difficult educational outcomes or poor health outcomes or low medium income, they all graph onto this Black Baltimore concept. And I thought, well, it would be great if I could try to do that. And in fact, I have done that. And what I'm going to do is show you how you could do it as well. And as I hope it will make sense, I think it's something that has many, many different applications across a lot of different domains. And indeed, one of the major points here is that it's not, we shouldn't be thinking about things separately, that health and education and economy and housing and law are all separate. Really, they're all interrelated when you're talking about something as serious and as troubling as structural racism. And if you only look at it in your specialized little area, you might be frustrated at attempts of reform because something that happens in another arena tends to undermine it. So the goal really is to introduce you to what I have done. And I'm going to introduce you to a particular stack. Now that word stack, S-T-A-C-K, has a very particular meaning in the world of computer programming. You can think of it as just like an environment. It is the way that you get things done. And I'm going to introduce you to what I think is a very relatively simple stack that involves Jupyter Notebooks and Python and a couple of Python libraries. I am well aware that most people in this audience probably don't have a coding background, but I'm also aware that some of you do. And I'm going to invite everybody to try to sort of work with this at whatever level of abstraction works for them. If you don't understand it all, don't worry about it. It's more about understanding what you can do. If you're just getting into coding and you have some specific questions, I'm happy to answer those. Of course, I've also put all of this code up onto GitHub. If folks don't know what that is, I will, well, actually, I'll just share my screen and show you. And actually, I'll probably just move to the screen sharing portion of the presentation for now. GitHub is a place online where you can share code. And so all of the code that I'm going to be showing you now is up on GitHub at this particular address, Colin Starger, Black Butterfly, BNIA. And so you can reproduce everything that I'm doing on your own, okay? All right, so with that said, I'm just going to move on to explaining the stack that I have and walking through this. It's, as I was talking to Seema before, it's always perilous to do something like a live coding demonstration, but we're going to blaze forward and hope that it works. The first layer of the stack that I'm going to explain is the Jupyter Notebook. Jupyter Notebook is basically an online platform that allows you to write code and save code, and it executes on your machine but it works inside a browser. So I'm working inside of Google Chrome right here. To get Jupyter Notebooks, you go to a place called anaconda.com. It's called an Anaconda distribution. You go to products and you get the individual edition, all right? And it will download a package of things. It's a data science package. And after everything's unloaded, you get a window that kind of looks like this. It can do lots of different things, okay? You end up clicking Jupyter Notebook, and that opens up in your browser a little field that looks like this. File system, and you can open new notebooks and get right to coding, okay? And so this is the notebook that we're going to be dealing with. Now I'm going to tell you just a little bit about notebooks. You can do them in different languages. The most common one is Python for sure, but you can also use R, which is another very good data science language. And as a matter of fact, the particular stack that I'm using within Python uses a library called Pandas that I'll talk about that is very much like what R does. It's a concept of data frames, which I'll explain a little bit more, but these are something that you see in R. It's something that you see in this particular Python stack. But every Jupyter Notebook has cells. So this is one cell at the top, this is another, this is a third, and cells are basically of two types. One type is kind of a text cell. That's what this is here, right? And the text cells are actually written in something called markup if you want. If I was to double click on this, you can actually embed HTML. You can have very nice looking text cells if you want, or you can have basic looking text cells, right? But the second kind of cell, the main one that you do your work in, are kind of the code cells, all right? And so you'll see in this notebook sort of comments and then code. And then in each code cell, you press run up here, or you can just hit shift return. There's shortcuts, a million shortcuts to run the code that's in the particular cell. All right. So just to review, we're inside a Jupyter Notebook. Anybody that wants to see the notebook can go grab it for themselves on GitHub. And the other thing that's on GitHub is a CSV file that stands for comma separated value. It's basically like an Excel spreadsheet. It's something that can be read like an Excel spreadsheet. That is information that Seema and the folks at BNIA gave me with the necessary addresses and names of the different indicators. I'm going to assume everybody on this call has a basic familiarity with BNIA and the indicators that they have, although I'm happy to elaborate on that if people have questions, and we're certainly going to get into depth. But that CSV file is the other part of what you need, and it's also up on GitHub. All right, so now I'm just going to start walking you through and giving you a demonstration of this code and show you how it can be used to sort of produce different visualizations that ultimately show the black butterfly. So as I say here, the first step is to import libraries. Every programming language, you don't want to invent everything on your own. People have written all sorts of code that you can reuse, and it can do fantastic things. And as a matter of fact, if you're lucky, you have to write very, very little code, and you just use the code that other people have written. And that comes in the form of libraries. So here I'm going to be importing a bunch of libraries. I'm going to run this now. You're going to see a little star there, which means that that cell is running. And it's going to import the requests library, which allows you to access APIs, allows you to access kind of things over the web. The Pandas library, which is what I described before, which is the main data frame library for Python. Data frames being essentially, think of a data frame as like a particular sheet in Excel that has columns and rows. And that's the main way that we're going to be doing all of our work here, is manipulating columns and rows in data frames. Then there's a library called MatPlotLib, which is a visualization library that will allow us to visualize the content of data frames in a visually pleasing way. NumPy is a a mathematics library that is used in Pandas. It's just useful to have it there separately. And Geopandas is a specialized Pandas library that lets you very easily deal with GIS, which is to say Geographic Information Systems data, the kind of data that BNIA has collected so amazingly, right? And so those are our main libraries. You'll see that PD is going to be my short version for Pandas, and GPD is going to be my short version. We'll see it in variables up to come. All right, so the comment says the next step is to import the CSV file with BNIA API information into a Pandas data frame. And I'm going to sort of read the code to you first and execute it. So I'm creating a variable called API_df for API data frame. And I'm calling the Pandas library, and I'm calling a function called read CSV, and it's going to read the name of that file, right? And then I'm just going to set the index of that file to the short name column, and I'm going to show you what it looks like. So if I go there and I press run, you'll see this last line here, API_df.head, as this comment, and comments in Python, you make them after a little pound sign. This code isn't executed. It simply shows the first two rows of the file. So it's the head of this data frame, the first two rows of it. And you'll see the index here is the short name of the what do you call it? The indicator, right? And then it's the indicator number 1. That indicator is total population. So TPOP_XX is the indicator for total population. And importantly, this is the API address. It's an HTTPS. It's the address that BNIA says, if you want information about the TPOP indicator, you're going to have to go to that address. Okay. So now I have all of the information about BNIA's APIs in just one data frame. All right. And what I'm going to do is I'm going to manipulate the information that's in there to pull that information back. I'm actually going to use the API. All right. And so I had to write 2 functions, right? So as the comment here says, functions to manipulate information in API_df permits users to load indicators by short names into Geopandas data frames. So for those of you that are familiar with coding, this won't be anything new at all, but for those of you that aren't, when you write code, you tend to write little snippets of code into snippets that you call over and over again called functions. And there's 2 functions here. Each of them is defined by the def keyword. One is called getGDF, which is a geo data frame. I called it that. And the other is getGDF from URL. And this is the outside one. This is the one that gets called first. And it takes as a variable the short name, the name of the indicator that you're interested in, and the level. I won't explain that for a second. And basically it gets the URL from the API_df and passes it to this other function. And this other function I found, and Carlos and the other technical folks at BNIA, might have a better explanation for this, but I found it was easier to add a little bit of extra string verbiage to get what the information that's in the API back in a clean way. And you'll see here, there's a little thing that says print the URL, which when we execute this, you'll see what happens. And it's going to use the Geopandas data frame read file URL function. This is very, very powerful. Geopandas basically has a built-in function that if you give it the right URL, it will do all the work for you. You have very little work to do. So while some of you might see this as a little bit confusing, you could at least appreciate that there's not very much code here, right? And so if I run that, now I can show you an example, right? So there is an indicator called percentage of African Americans in a neighborhood, right? And all of the indicators have XX to it. So if I am to, and that's just this is the indicator name, and this tends to be whatever year. So percentage of African Americans in 2019 would be PA 2019, or in 2017, PAA 17, like that. And so if I just now call my function getGDF with the short name PAXX and display the first 2 lines of that, this is what's going to happen. You see it printed out the name of the URL where it got the information. And here are the first 2 lines of my new Pandas data frame that has all of this information about the percentage of African Americans. And in each column, well, the main columns you have to worry about, CSA 2010 is the name of the neighborhood, right? So here are the name of the neighborhoods. I think there's 54 or 55. And then here's the column that will say, what was the percentage of African Americans in that neighborhood in 2010, 2015, 2016, so forth. And here is this key information on the shape of the neighborhoods, the ArcGIS information that's going to let us graph it later. And this is now all in this little Geopandas data frame, right? I said before that you didn't have to worry about the level here, but for those of you that have been working with BNIA APIs before, you might know there was a recent excellent upgrade that they did that allows you to look at citywide data rather than neighborhood data. So I'm just going to show you, for those of you that are interested in that, if I run it and I specify the variable of level equals 1, it will tell me the citywide percentage of African Americans in Baltimore City. So in 2010, it was 63%, 2015, 62%, and so forth on to 2019, which is 61.77%. I'm not going to return to that level, level 0. From here on in, I'm going to just use because that's what we want to look at. But just so you know that the functions that are presented here are able to do that. All right. So we have successfully loaded information into something that I call PAXX data frame. And now I'm going to show you how to actually plot it, right? So I've written another function. It's called plot standard. It's going to take the name of the index. It's going to take the year that you're interested in. And right now I'm just defining hard coding how large the figure is going to be, 5 inches by 5 inches. And there's other variables that you can specify, whether you want a legend and what your color map is. I'll explain those a little bit more. And it just calls this function, getGDF, which I showed you before, get me my data frame, based on what the short name is. It's going to insert the year to choose the right column, whether it's PAA 10 or 15 or 16 or whatever it is. And then it's just going to call a function that's part of Geopandas, which is plot. Very simple. You tell it the column of the data frame, you tell it some other information, and if I run it, it gets it, and all of a sudden, we now have a Choropleth map, all right? So for those of you that are unfamiliar, Choropleth maps are heat maps. And the darker the color, the more of that particular variable of interest is. Since I looked at the percentage of African Americans, and I didn't specify what year, so it just defaulted to 2019, these are, the darker ones are the black neighborhoods. This is the wings of the butterfly, and this is the white L, all right? But what I want you to recognize is that with very little code, I just pulled that in from BNIA's website, and using Geopandas, I just did one line and it plotted it. All right, now we can do different things. So for example, if I want to pull in PAXX again, but let's look at 2018 instead, and let's make it bigger, 8 by 8 instead of 5 by 5. And this time I don't want this legend here. This legend is saying this is a sort of less than 20% African-American neighborhood, less than 40% African-American neighborhood, etc. I want to get rid of that legend, and I want to use purple colors, right? So if I run that, it's going to pull it from the website, and all of a sudden I have a purple map, right? Now, as you might imagine, there are millions of different ways that you can map these things, map anything that's in there, or make maps, millions of different colors, millions of different variations. It's perhaps a problem with Python that there are so many different options. There's so many different ways to do things in Pandas and so many different ways to do things in Geopandas. One key when you're learning is just to figure out how to do something simple. And I've therefore tried to provide a relatively simple model. Now, again, I'm very aware that folks that don't have a coding background will say that doesn't look simple at all, right? But for those of you that can figure out how to get into that, and I'll say lots of people, really anybody, I believe, and this comes from experience, anybody that felt comfortable in high school algebra and high school geometry is able to code. I teach a class, as I said, called Coding for Lawyers, where I teach law students who are not known for loving math, how to do this very stuff that we're talking about. And again, as long as they have a basic appreciation of variables from algebra and a basic appreciation of a little bit formal manipulations from geometry, this is accessible. If not, if that doesn't describe you, or you just simply aren't interested in this, I hope at least you can see how we can tell a story using this information. And so that's what I'm going to shift to now, is telling you a little bit of a story that I'm developing in the paper that I'm writing with Professor Colbert, which we're calling A Butterfly in the Time of COVID. And the first step in that was for me, so this is another cell. And as I say, the code below here is used to create a grid of maps that is the current figure 1 in my draft article. And the first thing that I did is I created a list of all the indicators that I was interested in, right? And this is in a particular array format or list format that's particular to Python. I'm just going to let you know what they are. This is the percentage of African Americans. This is the percentage of female head of households. This is the median household income, etc. The people that don't have vehicles. I went through all of the indicators and thought which of those would it be interesting to compare to each other. This reverse list is simply reflecting that some of the indicators, more is better in some sense, and some of the indicators, more is worse. And so when I'm looking to describe the effect of the black butterfly, the notion of disadvantage being distributed through this hypersegregation, something like median household income, the higher that is actually, the lower that is, should be reflected in a darker part of the chloropleth in order to follow it. So this is just a list of what I called the reverse indicators, where less should be lighter as opposed to the standard where more is lighter. So I created this list, and I'm not going to really walk through this code, but I'm just going to let you know that I created some functions. Again, these are functions to collect all of these indicators into giant collections. And so I'm running that code. And so now if I run this line, you're going to see a bunch of URLs from BNIA getting hit, and it's going to put them into this collection variable using that get collect function. All right, so it's going to take a second, and it's hitting the BNIA servers and getting each of these things. Again, when you're running in Jupyter Notebooks, you see a little star there. It means it's sort of thinking. It's still taking time. So we're going to wait for that star to go away, which will take just a second. All right, so there you go. So now it's finished. So now I have everything in the variable that I want. Again, now I had mentioned this notion of CMaps. The MatPlotLib library has lots of different ways that you can make things pretty, different types of heat maps. And it was one reason I love the BNIA website, but you don't have as much control over the size of the visualizations and over the color of the visualizations as I wanted. And it's not easy to put them all in a single grid, which is what I wanted. So this is a bunch of variables that I created to let me cycle through different color schemes. All right, so again, not to worry about it too much. Here's a long and somewhat ugly function, but this is going to be the main function that's going to create the figure, and it's using all the functions that are written above. And in the end, it's going to create a grid of maps and return a key. And so what does that look like? So let's just run it. So again, here's the name of the function is plot check. And I have a little line of code that says key is plot check. All right. All right. Fingers crossed, it's going to work. It worked. Beautiful. All right. So now here is my grid of maps. And what I did is I cycled through, and you can see the short name is on the top, and I used a different color for each line. What I hope you can see, and we can demonstrate this mathematically, and if it makes sense, I will show you mathematically how these are all correlated. But you can see the same basic pattern in the percentage of African Americans in 19 repeating in each of the indicators, sometimes more, sometimes less. This is percentage of neighborhoods with vacant houses. The wings seem a little clipped here. This is the percentage of neighborhoods with no household internet. The left side of the wing, the west side of the wing is much larger, seems a little more. You can see that it's not exactly the same. And yet you can see that the same basic pattern is repeating itself over and over to me. And I have to say, as a visual thinker, again, we can look at this mathematically in a second, but as a visual thinker, this is a powerful indictment of structural racism. And it's a powerful indictment that is rooted completely in data that has been verified by BNIA and is open source and available for the entire world. And we can see that you're not going to be able to solve one problem unless you grasp this whole situation, unless you understand that everything is related and the type of hypersegregation that Dr. Brown is talking about isn't just the product of one simple system, and it's not just the product of intentional discrimination. Rather, it's the product of a system that just kind of has a lot of inertia, doesn't care, and advantages some people and disadvantages some people, and has all sorts of implicit biases built in. But to me, the density of information that is available in this is very, very powerful. Now, of course, it's a little hard to read all of those. And so I told you I put it all into a variable called key. If I just, in Jupyter Notebooks, if you just print the name of type the name of a variable, it will tell you what's in that variable. So I'm going to ask, what's in my variable key? And here it is, right? Percentage of African American, residents that are Black or African American, percent of children living below the poverty line, percent of the population over 18 who voted in the last election. And here in the comment are the ones that are inverse, the so-called where lighter is more rather than less. Percentage of 9th to 12th grade students that are there. Now, I spent a lot of time in coming up with this, looking through the indicators that to me both best visualized it and you know, had a distribution across different arenas, economic arenas, health arenas, etc. There's lots of different ways that you could show this same basic concept. And so here I have coded another example just to show that. This is going to be a 20 indicator grid. So it's even bigger. And it's going to, the same basic type of code from before, as it goes through and it hits, it's pulling all of them in from the BNIA API and getting ready to graph it or getting ready to put it into a collection. Now it's done. I see the 15 is there, and I can just, I'll run the same thing, and I'm going to use a different set of maps. It's going to think for a second. It's going to hit Geopandas and crunch all that code. And then here it is showing it up that way, right? And so it's a much bigger grid. So this code is flexible. I could do smaller grids. I could do bigger grids. These are using a different type of color sequencing. And again, you can see that same basic pattern, but some of them are definitely less. This ready 13 seems to be pretty even, for example. It doesn't seem to have that same basic pattern. And if I wanted to know what ready 13 is, I'll do the same thing and echo my key variable, and ready 13 is kindergarten school readiness, right? And so it appears from this. that back in 2013, which I think was the last time this data was connected, they didn't seem to have, at least the testing didn't seem to show the same kind of disparities that we see in other things. And that's another interesting thing that can come out of an examination of this data, is that not everything has the same disparity. And not everything is all bad news. And maybe you want to look in and visualize areas where something positive is happening. And this basic stack would allow you to do that. And you know, you could write additional code, or you could work with your coder friends to do that as well. So the last thing that I want to do, well, actually I want to do one very small thing, just to show a trick that I think is neat. And then I want to talk a little bit about correlations and the mathematics of this all for those of you that aren't visual thinkers. Then I just want to open it up to questions. Here's a little trick that I just think is so neat about pandas, and you'll forgive me for geeking out, but by now I'm sure you're unsurprised that I'm geeking out, since that's kind of the tenor of the whole presentation. But there's something that you can do that will take the contents of a data frame and put it into the clipboard. And so if I run that, I've now got the contents of this key in a clipboard. And if I go to Microsoft Word and just press Control V, right? If I just paste it, if I highlight all of this and go to table, convert text to table, I'm just going to fit the contents, it just puts it into a beautiful table straight away. I'm super impressed by that. Maybe you aren't, but I found that as I'm writing, as I'm producing my scholarship, this to be an extraordinarily useful thing. But that's just a little side note. All right, so what we're seeing in this is a visual kind of representation of something that can be understood mathematically. And it can be understood mathematically as how much correlation is there between when numbers in one set, in the percentage of African Americans in a neighborhood, and median income rises. And for the statisticians out there, or the data scientists, or even people that are sort of vaguely familiar with this word, the notion of correlation is one that's familiar. It's very powerful, and it's become newly powerful when we have so much data in an era of big data where we can do multiple correlations. And Pandas, of course, has a way that you can create correlations. And what this code does is it basically creates a data frame that allows you to compare all the various different indices that I have to each other. And it creates this giant matrix. And in this particular type of correlation is called a Pearson correlation. Pandas lets you do different ones. And if it's a correlation is always a number between -1 and 1. A 1 means a perfect correlation. For every unit that one index moves, the other index moves in a similar kind of unit. And so any indicator is always going to have a perfect 1 correlation to itself. And under the Pearson kind of way of looking at correlation, anything over a 0.5 is considered a high correlation. And so if you look here, you'll see the numbers are tremendously high. There's a few that are below 5, but the vast majority of them are not below 5. And if you average them out, I average very quickly, just using a couple of lines of code, I can average out all of the correlations of a particular column to all of the other, basically what's the average correlation of one indicator to all the other indicators. And the code that I wrote excludes itself, so it doesn't improperly weigh that 1 where it's being compared to itself. And look at this. These are the total average correlations of all the indicators in that first 16 that I'm using to each other. And you'll see the lowest, interestingly enough, is the percentage of African Americans. but it's still 0.63, which means it's a very high correlation. It's yet more proof, mathematical proof of that basic thesis that everything is related to each other, that hypersegregation is related to each other. But it turns out the thing that's most connected to all of the others is whether or not you have a vehicle in your household. And whether or not you're feeling temporary assistance, your family is receiving temporary assistance for needy families. And so this shows that as much as the black butterfly is a race concept and is inextricably intertwined with race, given our history from slavery through the Civil War, Jim Crow, segregation, redlining, everything, it's 100% part of it. This also shows that always class is part of it as well. It's about wealth. Not all African Americans are poor, but African Americans are disproportionately poor. Not all white people are rich, but white people are disproportionately rich. Poor white people are likely to be in the black butterfly. Some neighborhoods more than others, and they're likely to suffer from these other vestiges really of hypersegregation. But if we think of hypersegregation in both a class and race sense, that's most accurate. And so I'm going to stop my share for now. And I'm, again, fully aware that I've sort of been talking a lot and giving a lot of information. Hopefully it's pitched at different levels and you can understand the story. But I'm happy to engage in any conversations that folks want to have, either on a technical level or on an idea level, or a mixture of the both.
That was incredible, Colin, just incredible, and really powerful at the very end, what you showed. So feel free to raise your hand if you want, or feel free to unmute yourself. This is a meeting situation. If you don't want to type it in the chat, you just want to talk, hopefully you all were equally moved by what Colin just showed us all. Anybody have any questions? Paris. And Paris is coming to us from Councilman Christopher Burnett's office, correct?
Oh, I didn't see Paris's hand up, but yeah, if you can call right now, I'm not seeing hands. So Seema, either you call on folks or just unmute yourself.
Yes, so thank you for the presentation. It was very eye-opening, and just to show the correlations across the board of how the L and the butterfly affects particularly citizens of color in the city. Other than, you know, this meeting that we're having, have you thought of, or are you interested in presenting this to city council bodies or you know, stakeholders in the community? You hear about the black butterfly effect a lot, and you know, I think some people have read the book, but I think even, you know, with your quote unquote nerding out, I think you actually showing it in the graphs for every indicator is like opens people's eyes, and I think it really does. And I think this information will really be great in being like a vehicle for change, especially at the end when you show that something that we've talked about anecdotally in our office, people don't have cars, and that is a huge barrier to getting a job or being able to, you know, have a sustainable life. And there we go, an indicator. That's literally the highest indicator that you can correlate across the city. So my thing is, have you tried to reach out to other, you know, stakeholders at other parts of the city to show this information? And what are the responses? And also, I would like to maybe email offline to see if we can get you to talk to our office about it in particular.
Well, thank you for that. And I really appreciate hearing that. I will admit that this is new. This is the first time I've ever presented it. I'm currently drafting a paper, and this comes literally out from the code that I wrote. But I have a feeling that this is, I've stumbled onto a way of presenting something that people already knew was true, but demonstrates it in a different way, both visually and then mathematically. So I would love to present it to more folks. I would love to try to increase awareness, but and I'd also love to empower people to kind of be able to do it themselves, right? I couldn't have done this but for the amazing work that BNIA has been doing over the years. And I wouldn't have thought of it had it not been for listening to Seema and knowing about Dr. Brown's work. And I wouldn't have the opportunity to maybe present it if you hadn't been on the call. So I'm a big believer in open data. I'm very, very happy to present it, but I can't give you the reactions of anybody else because you guys are literally the first people I've ever presented it to.
This is the world premiere of this work. But also, Paris, in general, BNIA gives what's called the State of the Neighborhoods briefing to the council. It's been about 2 years that we've done it, and maybe we could do a piggyback where we can show the state of the briefing and then have Colin join us too. We could do a 1-2 punch. Be happy to do that.
That would be great. I see a question in the code in the chat where someone said, "Can you show what an error might look like in the code and how to correct that?" It's in a way a very simple request. I'll do something like that right now, but there's a lot to it. But it's good. I think it's an interesting kind of question. So let me just very briefly share my screen and go back to my notebook. If I was to just go right here and type something that doesn't make any sense, for example, I just type that and I run it, it's going to give me an error. And the error here will say something describing it. And in this case, it's saying that it's not defined. And as you're learning to code, learning to read those errors and figure out what they mean, that's really how you learn to code. So since this isn't a class where we're going into it, I'm just going to leave it at that. But that's an excellent question. It shows that you're probably ready to start coding if you're already interested in how do I figure it out if things go wrong. My email has been requested. I'll say it out loud. I think it might be in the chat as well, but it's Starger, CSTARGER @ubalt.edu.
Thank you for pronouncing that, because I always thought it was Starger.
Yes, Starger is how my dad says it, so that's how I say it, but I've been answering to Starger for my whole life, and I've given up fighting that particular battle. There's a question.
Pearson correlations.
Yes. So the reason is that that's the default in Pandas. I have run it with other ones, but when I looked at it, I remember, so I'm not a PhD in anything, certainly not in statistics, but when I did a little background reading and I see that Fong has a question, I'll turn to that next. It seemed like it was worth it. There were no kind of bad reports on it, and so that's why I ended up using it. But I would be entirely open to people doing it differently, and the code, of course, can change that. Fong.
We actually, sorry, Fong, you're probably going to answer this better than me because you do this for a living, but we actually did some analysis of the Pearson correlation versus the one that ranks them first before, like the way by rank, by which one?
Spearman.
Yeah, Spearman. And because our data is actually quantitative data, it works better to do the Pearson versus the Spearman. But yes, if you want to answer that question or ask it.
I wish I could say that I had done that same thing. I just remember reading it and seeing that it seemed right, but I hadn't done a comparative analysis on your data, that's for sure.
So you might have seen me pull up my non-parametric statistics book as I was thinking about this, because I just taught this a course about different correlations. So that was part of my question, which was already asked. And one thing not to get too technical, but certainly Pearson makes more sense. But I was wondering about this whole idea of averaging correlations, and that's a little unusual. And I might offer instead having some kind of, I think seeing all of them as they are is certainly powerful enough in terms of like drawing conclusions. And I think in some advocacy work I've done, I've had like color-coded charts, red is bad, blue is good, or whatever, and it's really, I think some of that stuff really pops when you kind of list it all out in that way with a nice visualization and not summarize it too much, because I think as all of us, and I think as Paris suggested, some of the individual variables are really what makes the story interesting. I think, as we've all said, we know what the black butterfly is, we know these implications, but once you start seeing specific instances of access to cars or low-income tax credits and things like that, that's sort of where it hits me differently as a Baltimore resident who spends time swimming through all this stuff. Those are the things that kind of get me, and so that's something I would consider. I also, as a mathematician, I would argue with the use of the word prove, but you're the lawyer, not me.
Well, I went through a whole section in my paper arguing about the philosophical differences between correlation and causation and the nature of proof. So it may have sounded like I was being loose with my language there, but I didn't mean to be. It's very different from a causal proof. But when you have that many data points that all point towards the same thing, the possibility of coincidence to me strikes me as very low, but the causal mechanism hasn't been specified. Thank you, though, for that point on the risks of averaging out the correlations. One reason why I did it was in the appendix, I print of the paper as it's going so far, I print the entire matrix, but the entire matrix is huge. It's 16 by 16, and it's very unwieldy. So I was just trying to think of a way to get a sense of it. And I realized that maybe it's not a statistically good metric when you look at the average correlation across everything, but it struck me as the least being what it was. So I might want to hit you offline to talk more about those dangers, and I certainly appreciate that because I'm not a mathematician. I mean,
I'll throw in one more, and I'm happy to do that. I'll put my email up to you, but also these sort of correlation analysis are incredibly sensitive to outliers, and it's all outliers, and to some degree, when I think about this a lot of the time. So I think being careful about that would be something I would, as you're kind of looking over your numbers again, being really careful about that sort of thing, and averaging kind of in its nature smooths some of that stuff over.
Okay, great. Thank you.
Billy, were you suggesting a heat map of the correlation matrix?
Yeah, just to that's like one strategy to make it less like overwhelming, because if it's just like a giant matrix of like numbers, it's sort of hard to sort of pluck out like which of those numbers are largest if you're just trying to look at them individually. Sometimes right. like overlaying that with a heat map where and you could sort of I like your approach to like having the absolute value, right? So just like that could be one way of sort of saying, here's a way like visually of seeing in that matrix which of these numbers are sort of furthest from zero in either direction. With that wouldn't necessitate like averaging them. But again, Fong is definitely the expert on like ways of sort of presenting these things in ways that don't sort of muddy the waters. But that's one strategy that I've seen folks take.
Perfect. Thank you for that, Billy. And I'm just writing down Fong's email he put it in the chat. If anyone else has a question or comment, just throw it out. Pardon me as I'm just reading and writing just for a second here.
And we just put in the survey evaluation. If you could fill that out too, so that we get a better sense of how to do this. But I feel like if we got the lawyers and the mathematicians and the data visualization folks from MICA together, and then actually the people that did the analysis on the correlations were public health biostatisticians, if we got all of them together in a room, we might be able to figure this out. The best way to kind of convey to precisely folks like Paris Gray, who's in the council, using what seems like very deep data and data science techniques, and yet is all about making sure that we have better neighborhoods, which what the council cares about. We're all after the same thing, and yet from our individual disciplines.
Yeah. And that's one thing that I'll just emphasize, like I'm going to be speaking primarily in my paper to a legal audience. So I'm interested in just sort of pushing and then provoking them to think about it in a new way. And so sometimes in what I would write for a legal audience, I'm going to be a little bit less, I wouldn't want to be wrong about anything, but I would be a little bit less concerned about being sort of mathematically complex or nuanced than I would if I was presenting to different. So, but I think that idea of bringing everybody together, because that is really ultimately my goal as an academic, is to work and collaborate with other people across fields to make Baltimore better and to make our society better.
I think if none of us learned anything after Freddie Gray, it was that we all have to actually do things differently. And coming out of our disciplines is part of that. And so I was wondering how challenging was it for you? I know you obviously have a background in computer science before becoming a lawyer. How challenging was it for you to set up that GitHub so that it, I guess the stack is what is a way to kind of get people into what you're doing, even if they never saw this video? Yeah.
So GitHub is like a nightmare, really. I'm pretty good at coding, and I can do a lot of things, and I'm always scared when I try to do something in GitHub. I don't know why. Maybe it's because I'm old. I'm nearly 52 years old, and it's just so different from the version control that I had as a young pup. But it's also undeniably powerful and worth learning. And there are little apps that you can use. The desktop app, you don't have to be in there in the command line and do everything. And so to set up that BNIA GitHub that I did was very easy. I haven't heard from anybody if they were able to download the notebook and make it work, and download the CSV file and make it work. I hope that they did. Yeah, so I think I wish GitHub was a little bit easier than it is, but it's definitely kind of the #1 game in town for sharing code, and it's free, and it definitely works. It works very, very well. So I'm for it, but I'm never going to say to anybody that I think it's easy, because I don't. But get the desktop app, and hopefully you don't have to go back and undo versions from prior times, because that's when it gets hard.
Thanks to Sean for saying that he has run it open source in Canton. So that's a good sign.
Right.
All right, we just have a couple more minutes. If you haven't done the evaluation, please do that. If anybody else has any questions, last question for Colin.
My dirty little secret with GitHub is that I just renamed the repo, create a new one, upload to the new one, and then delete the one I was having a problem with.
Yeah, totally. I actually already did that once with this one.
So what's more is that I've been a little bit silent sitting in the back. You were doing a really great job, and I love to see that everything you were doing is right down our alley. It really is. And what you've been doing with the code, I think there's a lot of room to talk about this. Further aiding and developing, creating code that aids in the visualization of our data. So 2 things that I think that you created, or like you kind of presented today, that was really salient, and internally BNIA has been working on producing to further give out to other developers, was this API crosswalk. First and foremost, I think you might have pulled that internally from us, but we can't specifically locate that file. And then just recently, I created an alternate version that we're hosting on GitHub. So Seema's talking to me right now. She says, "Hey, let's make sure that all the information, is consolidated between the two, get them out." And then also the small multiples, these different forms of visualization of the correlations of these data. They're very powerful, and you're right. It's to see it, and this the Python notebooks are a great way to share and spread that information. So I see that, and I like to work with it, and especially because it can be reapplied. Like, you can take small segments of that and push it into other locations. And I think I'm actually going to follow up with you, because just recently, not like 1 week ago, so it's still a little bit fresh, which is why you might not see us presenting it right now, is we have released a new library, vital signs library, where I think somebody was talking about having a hackathon, and this is kind of the things we're thinking about, because the library is fresh, it can be improved. I'm a good programmer, I'm not the best, but each of these, like every single one of our data creation queries are written in Python, and we encapsulated them as little functions. And so I was thinking of creating a randomized, an anonymized kind of data set for each of our data sources, and then having people look over and see if they can improve the queries. The open source nature of everything is really good. And everything was written in a Python notebook. And so the documentation is available as an IPython notebook. And then I'm using special tooling to convert them to both documentation on just how the code was written, and then also the libraries. So this is something, if you're interested, you can talk more about with me. Outside of this file signs library, just recently we published another addition to the something we're giving for the data science core, and we hope to expand to a broader base. But it's called Data Play, and it's a data visualization, data analysis kind of library. It helps with the intake of data of different formats, and then the visualization using it really uses a lot of Pandas and Geopandas. It's just kind of a wrapper over this stuff. But definitely, there's a section on correlations, and it does do network diagrams as well as heat maps. And then the very last thing is visualization and dissemination of this information. So IPython is really great. NBDev. Yeah, IPython, these Jupyter Notebooks, Google Colab, these are really great resources.
We should definitely keep chatting.
Yes.
Oh, yeah. Exporting the file results.
I just want to let, for those that are still on the call, let everybody know that I'm leaving on a 2-week vacation on Friday. So I might not be the most responsive over the next little bit, but that's not because I'm not interested, just because my vacation has actually started.
Well, thanks.